Hello, my name is Sophia. I'm an elementary school student at Vista Oaks Charter School. I also have a dual enrollment with community colleges and a university. I'd like to tell you about my favorite subjects, and in the end, I'll show my list of classes which I took in the last 2 years and this year's fall semester. 2020 was particularly a COVID year, and only online classes were conducted for March. This year was entirely a COVID year, so there were only online classes. Na, in Deutsch mache ich den Aufsatz von 4. zur 5. Klasse. Ich mache auch die Inhaltsangabe, habe nur angefangen, das Wissenschaft, das Anton wie 4. Klasse und ich liebe meistens das Anton und das Wissenschaftsbuch. Dies ist ein Text, der wir kürzlich im Aussatz behandelt haben. Wenn es gut läuft, hat ein Fahrradhelm zwei Eigenschaften. Er schützt ordentlich und er sieht gut aus. Es mit den Gussaussehen klappt nicht immer, finden viele Kinder. Und wie gut es schützt, wird an Maschinen getestet. Man kann ja schließlich keine Kindertests für so Unfälle bauen lassen. Im Bayerischen Landberg steht ein solches Testlabor. Dort prüft der Autoclub ADAC neue Kinderhelme. In der Werkstatt ist ein rosafarbene Mädchenhelm auf einen Kopf auf Aluminium gespannt. Dann drückt ein Mitarbeiter auf einen Knopf. Eine Maschine lässt den Kopf mit dem Helm nach unten sausen. Im Boden hält den Helm auf eine Ecke aus Stahl. Die ist so spitz wie eine Bordsteinkante. Er eiert herum und hat eine Delle. En français, moi je fais l'histoire, le 11e à le 12e siècle, et moi j'ai aussi le livre de collège, qui a la conjonction, la grammaire, l'orthographe, la littérature et la rédaction. Et ma favorite partie, c'est de Paris, qui est la capitale de la Royaume de France. Ici, qu'est-ce que se passe, c'est qu'il avait un roi qu'il est UKP. UKP, qu'est-ce que s'est passé, c'est qu'il a décidé de réunifier la France. Avant, il avait beaucoup d'espace et il avait un roi qui pourrait contrôler tout de Paris à Orléans. Et ça, c'est pas beaucoup. La France est énorme comparée à le domaine royal, qui moi j'ai juste dit. Tout le reste est contrôlé par les seigneurs. Mais UKP a décidé de faire quelque chose de différent. Il a décidé de faire une dynastie, les Capétiens. Il a aussi décidé de faire quelque chose d'autre. Il a décidé de faire que toute la France est contrôlée par il. Toute la France et le domaine royal est contrôlé par UKP ou le roi de France. Philippe Auguste a décidé de continuer, a décidé de faire beaucoup de batailles. Une de ces batailles qui est la plus importante, c'est la bataille de Bouvines. Cette bataille a été finie par France gagnant en 1214. Cette bataille, c'est quand ils ont décidé de faire une bataille avec l'Angleterre et ils ont le gagné. Ils ont gagné des autres batailles dans ce même an. Philippe Auguste a aussi décidé à faire à Paris la capitale de la France. Avant, il n'avait pas une vraie capitale de France. Tout était contrôlé par seigneur et UKP, c'était seulement comment on commence. Tu peux voir que la palais de France ou la cité, Paris de la cité, il a beaucoup de choses. La Seine, la tour d'horloge, le Parlement, le logis de roi, la Sainte-Chapelle, la chambre de comte et l'enceinte du palais. Tu peux voir ici que c'est seulement dans un espace et toutes les autres personnes qui sont ici, ça, c'est les paysans qui ont besoin de faire choses pour Philippe. Comme normal, les paysans font toujours choses pour Philippe le roi. In EP Biology, we most recently covered the evolution of the genome, but I have two favorite topics in AP Biology, cell communication and biotechnology. A part that I loved in this class were the regular Kahoot games to refresh your knowledge. Now let me explain one of my favorite parts of the cell communication chapter. Now, it starts with only one molecule. It's called epinephrine. And then it binds to another molecule which is much bigger than the epinephrine. It's called the G protein. And you can see here, the G protein right here, it's way different. It's different because what it does is activates a bunch of G proteins. From one molecule, we don't get 10 molecules, we get 100 molecules. That is so many molecules compared to just one, but it becomes even crazier. But first, it starts with the G proteins activating adenyl cyclases. Well, how will these adenyl cyclases help us? Let's see. The adenyl cyclases activate the process of turning ATP, which is a very important molecule in all of biology, into cyclic AMP, which is typically a second receptor in a cell communication reaction. But you don't have 100 molecules anymore. You don't have 1,000 molecules. You have 10,000 molecules. That is so many molecules. But cyclic AMP is a second receptor, and that means that it carries the response that the G proteins had to another molecule. But what is that molecule? It's a protein kinase A. Now, a protein kinase A, the CAMP or cyclic AMP bonds to that molecule, and it activates a bunch of protein kinase A's. Now, the protein kinase A's activate a bunch of phosphorylase kinases, but how did it go by a power of 10 even when it was responding? The answer is this. Every single protein kinase, so every single protein kinase, like something like this, has 6 response sites. So since we already had 10 to the 4th molecules, we can have even more. So 6, 1, 2, 3, 4, 5, 6. Where a tyrosine bonds with the protein kinase. And then the final process until the response is that these phosphorylase kinases that get produced from the 6 receptors become the glycogen phosphorylases. So glycogen phosphorylases, what they do is that they activate the response. Now you can already see the word glycogen here. It's a clear hint of what it's going to be doing. It's going to be activating the process where 10 to the 8th molecules of glycogen become 10 to the 8th molecules of glucose 1-phosphate. And yeah, and why did we have to do that? Well, to make it more usable by the cell. Like glycogen is kind of hard to deal with, but glucose 1-phosphate, no. OK, 中文科学课。泥石流是我在课堂的最喜欢的部分。泥石流是多种形式的质量浪费，可能包括方位广泛的地面运动，例如落石、深部斜坡崩塌。泥石流的自然原因是什么？让我们做一个实验来找出。第一个，首先用松散的土壤制作生出的模型。第二个，接下来在土谷模型的斜坡上观察土一中 H 发生的现象。最后，增加水量，在斜坡上形成更大的水流，再次观察 A 出现的现象。土一中 A 发生的现象是否土二中 C 处发生的现象相似？是啊，土一中 A 发生的现象是来自泥石流的现象。So college prep English is actually 2 classes, the 9-10, which I took last year, and the 11-12, which I'm taking right now. Now, there are 3 parts that I liked in this class. The first one is that I like the quizzes and practice on vocabulary.com. My other favorite part is diagramming on Let's Diagram because it's so fun. Also, I love that you can optionally sign up for presentations on 3 topics: vocabulary, grammar, and a literary term in Bedford. Så i svenska gör jag historia som industriella revolutionen nu, och jag gör också grammatik. Och varför liker jag mest historien? Där är många dokumenter om industriella revolutionen. Varför det blir mycket mer dokumenter om 1700-talet än 1600-talet till exempel. Jag ska läsa en text om industriella revolutionen. Den industriella revolutionen markerar en övergång från jordbrukssamhället till industrisamhället. Industrialismens första fas inleddes i Storbritannien under senare delen av 1700-talet. Jordbruket i Storbritannien hade vid den här tiden genomgått stora förändringar. Fram till 1700-talet hade bondernas jordar varit uppdelat i mängder av tegar eller åkerlappar som i regel var utspridda över den här hela bena som det bodde. Så till exempel, här har vi sån här 4 teg. Och här är en del för en bonde och här är en fjärde del. Så det betyder så här en del av den fjärde del, det delas upp. Det är inte produktivt. Men hur ska Sverige förändra det? Varför det var sån här för så långt? Det är bestämt att förändra systemet. Att tegerna slogs istället ihop till en stor jordsystem. Så det här 4 sakerna här, de går till en bonde. Och det blir mer produktivt. Varför det blir så vis mer effektivt också. Och det medförde att färre bönder kunde försörja flera människor än tidigare. Och varför så många människor immigrerade i Sverige, det var jätteviktigt på den här tiden. Okay, so in physics, my favorite part is acceleration, and we recently covered heat transfer and phase changes. At the end of the course, we get to present on any state of matter that is not a solid, a liquid, or a gas, or a material that doesn't just fit in one category. My topic is supercritical fluids, a material that just doesn't fit in one place. So you can see that acceleration, what is it? It's the change of velocity over the time interval. But what is velocity? Well, velocity is the change in speed over a time interval. So acceleration is the rate of a rate. But you might not really understand that, like, why is it like this? And why do we even need to measure this acceleration? So the reason we need to measure it is because of this. So let's start by thinking about some object. An object, when it stays, it has a specific position. It has a specific position that you know. However, of course, like any other value, position can change. And in this case, position changes. So what happens if an object's position changes over a certain amount of time? That's where velocity comes in. Velocity shows the amount a position changes over a unit of time. If position is constant, then everything else is constant. But if position is changing, it starts getting more interesting. Now, velocity, however, can be at least constant or it can also be changing. Now, if velocity is constant, nothing interesting comes. However, if velocity is changing, then things start to get interesting. Then how much is velocity changing per second? You might think. That's where acceleration comes in. That's what it answers. Position answers where is an object at a particular point. Velocity answers how fast is position changing per second. Acceleration answers how fast is velocity changing per second. So acceleration can either be constant or changing again, and constant acceleration, what is that? Constant acceleration is where an object increases by a certain amount of speed, but it increases by a certain amount, which you can add or subtract and get the right acceleration every single time. So, for example, 4 meters per second, 8 meters per second, 12 meters per second, and then the opposite of that. Okay, that is constant acceleration. Changing acceleration occurs, for example, when you have an object that is changing acceleration by powers of 2. So it starts at just 1 meter per second, then 2 meters, and like first it starts with like 1 meter per second, then 2 meters per second, then 4 meters per second. If you try adding 1 to 1 meter per second, then you'll get 2 meters per second. That's right. But when you add 1 to 2 meters per second, you get 3 meters per second. But 3 meters per second is not the right acceleration. That means it's increasing by an amount that you multiply or divide. That is clearly a changing acceleration. However, one last thing is that acceleration includes not just increases, but decreases. Sometimes we use the word deceleration for decreases in acceleration. So yeah, that is kind of shown, but acceleration applies to decreases as well. So the difference between acceleration and velocity can really be coined if you have stood in a crowded bus. If you stand in a crowded bus, have a coin and flip it while the object is moving, then you will catch the coin exactly how you threw it. However, if the item is changing speed, then it won't work. So when the object is changing speed, that won't work because what will happen is that you'll flip a coin and then it lands in a different place. It lands in a different place due to the increase, or it lands in a different place due to the decrease, or it kind of turns in the same place. Now, if you rapidly accelerate, then what you do is that you kind of like lurch behind. So you lurch behind. And when you rapidly decelerate, you typically lurch above. And that's why seatbelts are necessary. If you rapidly decelerate from somewhere out, for example, if you're a racing car, then a seatbelt would kind of help you and kind of stop you from cracking into the other seats of the car, especially if you're in the back. So what are supercritical fluids? Supercritical fluids. They are fluids between a liquid and a gas. These fluids have low viscosity and a high density. All supercritical fluids are miscible with each other. Before material becomes a supercritical fluid, it needs to pass a critical point. This point is where the pressure and temperature are large enough to cause the material to become a supercritical fluid. Let's explain a bit more about the critical point with the diagram I showed below. So here, you have carbon dioxide. And you have carbon dioxide in two different phases. One phase is the gas phase, the other is the liquid. Next, here you can see by this line, you can see there is still a gas phase that is clearly visible. However, one of these parts, this one, is a whole mix. So I'm going to label it as mix. This part is mix or mixture. And this part is kind of a different. This part is kind of like a different mixture. It's kind of visible. Then you can still see the border lines going over here around the same place. Here it is starting to get harder, so this is all part of a mixture, and the two mixtures are clearly visible between each other. The border is not really visible anywhere except here, here and like here a bit. This is where the border, like the border is actually notable. The rest of the border has already moved to the corners over here. Now here, you can see these mixtures are becoming less distinguishable. At this point, the material has already reached the critical point. So the critical point is where this material can become a supercritical fluid. So the critical point is already passed. So you can take a material like this and turn it into a supercritical fluid. Now, basically, the only problem with this is that the border is kind of barely visible on the edge when it's not supposed to be, but most of the border is on these corners. And the rest is that this is clearly visible as a mixture, and this is another mixture. So there are a lot of processes that kind of change until you get to this, the supercritical fluid. Everything has passed to the border right now. This is all a mixture and completely a mixture. It cannot be seen, so there's no differences between here and or here or here. You can't see any of those differences. So close to the critical point, small changes in pressure or temperature, they result in large changes in density, which allow many properties of supercritical fluid to be fine-tuned. So this is how this material becomes this. This is why it can be shown as being in the critical point. Supercritical fluids have many applications, and the main one being supercritical water. Supercritical water, like any other supercritical fluid, is tunable, but it's also environmentally friendly. Så i norsk gjør vi en biologibok om mange dyr og planter i Norge, og min favorittplante er kjernesild. Jeg skal lese litt om kjernesilder. Sildene kjennes lett på blomstene, som i midten har en fruktemne som består av to halvveis sammenvoksne fruktknuter ved hver sin griffel, omtrent som to horn. Sildeselten er en spesielt viktig slekt i nordlige og arktiske strøk, og de fleste artene hos oss er fjellplanter. Men vi har også tre varme, skjære lavlandsarter. Kjernesilder er antagelig den vanligste av fjellartene, og går ganske langt ned i åstrakter langs bekker og med skygg. Og den vokser på steder med rikelig og gjennomstrømmede vann, og krever lite av jordsmonnet. Mikkelte bok som heter Fjäsol i Finnemalum, og boken er oppholdsboken min. Boken er islandsk. Boken begynte av lille stulker som heter Fjäsol med foreldrene sine. Fjäsol alltid sitt midler at si at hun ikke at flytja, men hun alltid tar margavini i skolen. Så efter några veckor flyttar Fjäsol aftur. Her er litt av boken. Það gerir þú þegar þú ert orðin stór og farin að finna til þér, sagði mamma. Þú getur safnað peningum handa sjálfri þér, en núna áttu bara að vera að safna viti í skólanum og þannig finnur þú vel fyrir sjálfa þig. En þú getur alveg haldið tombólu. Hún verður bara að vera til styrktar einhverjum sem þurfa á söfnum að halda. Nej, sagde Fjäsol och Christer höfte. En ikke halda tombólu, frekka tek ég bara til. Jæja, sagði mamma, nú líst mér að þig. En þú lætur systurna í friði. Þær eiga ekki að taka til í ruslahaugum þínum. Nei, ég gerði þetta bara sjálf. Þú ert dugnarforkur, sagði mamma, faðmandi Fjäsol að sér. So, organic chemistry, it's a class with Professor Daniel Fried, who graduated from Yale University. Right now, we're covering different acid-base theories and the Kallikhiamycin mechanism. And my favorite part is electrophilic aromatic substitution. Now, electrophilic aromatic substitution is a bunch of different reactions in one. So here you can see the 5 most common ones. The first and most common one is halogenation, where you have a bromine or chlorine or iodine which substitutes for hydrogen. The second one is nitration, where a nitro group substitutes for hydrogen. The third one is sulfonation, where a sulfonic acid or SO3H group substitutes for hydrogen. The next one is Friedel-Crafts acylation, where an acyl RC-O group substitutes for hydrogen. But then you might think, what is RC-O? Well, R can be anything, just literally anything. C is a carbon, and then those two lines mean double bonds. And then O is the oxygen. And Friedel-Crafts alkylation is when an alkyl or R group substitutes for hydrogen. But what is the mechanism? So first you start with an aromatic compound, most of the time benzene. You take one of the hydrogens that is attached to that aromatic compound, and then you use up the other substance you have, for example, the nitro group, and then you put it with a positive charge, and then you put it onto the benzene, and then whack the positive charge to the hydrogen. And the hydrogen actually kind of likes positive charges, so it's actually understandable. But this method includes an intermediate, a carbocation. Now, it cannot be depicted exactly. It can only be depicted using 3 different resonance contributors. And it is used to take the aromatic compound, which makes it more stable, and make it aromatic again, kind of. Я занимаюсь русским языком по книжке Ольги Леонидовны Соболевой. А еще Я занимаюсь литературой. Одно из последних произведений, которое я прочитала, и мне очень понравилось «Вишневый сад» Чехова. En español, yo hice un libro de geografía que se llama Hemisferio Oriental. Antes hizo un libro de biología y también las ciencias de la Tierra. Mi tema favorito del libro Hemisferio Oriental es China en la dinastía Ming. ¿Qué pasó de China en la dinastía Ming? Antes necesitamos saber qué pasó en China antes de la dinastía Ming. Que la China estaba una de las civilizaciones que vivió muy largo tiempo, no como siglos, miles de años con muchas diferentes dinastías. Normalmente todas estas dinastías son controladas por emperadores de China. Pero en la dinastía que estaba antes de la dinastía Ming, la dinastía Zhou, ¿qué pasó? ¿Qué pasó? Es que la persona que se llama Genghis Khan ha decidido de coloniar la China como un mongol. Y después funcionó, pero solo parcialmente. Después, Kublai Khan finió la situación y China estaba controlado completamente por mongoles en la dinastía Zhou. Esto estaba tan problemático para China que decidían a cambiar cómo reaccionan a otros espacios. Ellas querían eliminar cualquier influencia que estaba de cualquier otro que los chinos. Y esto estaba realmente malo. ¿Por qué estaba tan malo? Porque el oeste ha decidido de copiar la China y ha decidido de hacer cosas que estaban mejores que las de China. Y la China no podía hacer nada porque solo querían cosas chinos en la inventación. Y después China no ganó. Ellos no hacemos. ¿Por qué el oeste ya ha colonizado América y Europa tenía una revolución en este tiempo? Estaba mucho mejor para Europa y decidieron a copiar todo. El oeste devenió mejor en tecnología y sistemas. Now, these were only some of my favorite classes because describing all of them would just take too much time. So instead, I'll show a list of all the classes I took in the past 2 years. So first, I'm taking a Chinese language arts class. Then I'm also taking a Chinese science class in Chinese, a Japanese language arts class, and a German language arts, the political system in Germany in German, physical science in German, French language arts, geography in French, medieval history in French, physics and chemistry in French, creative writing in English, chemistry in English, Tibetan language arts, meditation in French, but with Tibetan techniques, Swedish language arts, the medieval history of Scandinavian Swedish, runes, the Swedish cultural study, so study of Swedish culture in Swedish, Spanish, a language arts again, biology in Spanish, Russian language arts, Norwegian language arts and literature, modern history in Swedish, IMAX, which is the Institute of Mathematics and Computer Science, obviously in English, Old Norse, studying, Icelandic language arts, Icelandic geography, history, and culture in Icelandic, Algebra 1, history, geography, and science in Russian, physics in Russian, an art class, an introduction to programming class with Java, Italian language arts, studying Old English, earth science in Spanish, and Hemisferio Oriental. Hemisferio Oriental is a geography book in Spanish. ALPS geometry, theater class, debate class, literary analysis, introduction to philosophy, college preparatory language arts 11-12, and the 9-10 version. Math Circle from the University of Washington, Physics and then the problem solving with physics. These are two separate classes. Organic chemistry, which is the second year of the university level class that we're taking. So the second level of the university level class. Astronomy from the University of Arizona. Chemistry from the University of Kentucky. Physics from the University of Virginia. Biochemistry, which is a college level class. Computer science from the University of Edinburgh. The research paper writing class. Kung Fu, which is a PE or physical education class, Algebra 2, and Kodo, which is a Japanese instrument. So these are my classes, and some of them are my classes now. I also like my Kung Fu classes very much, and of course, my favorite sport, which is quote unquote, quote unquote not a real sport, stand on board. And I'm also an A's fan. Thank you to my school because next year I'll officially become a high schooler and will study forward to my associate and undergraduate degrees. Thank you for your attention and bye.